The second video on how to find the distance between 2 points. This is the distance formula. Often this is really intimidating to students, but it's not terribly bad. It can take some work to figure out what you plug in where, but I wouldn't let this giant radical down there intimidate you. Let's be willing to play with it a little bit. So this is basically a technique that can be used if you don't have graph paper. So if you don't have the opportunity to actually make a triangle on a piece of paper and count it off, or if you don't have the digital technology to do it. So this is a technique that will work regardless. If the points are really far apart, it will work perfectly fine, provided you plug the numbers in correctly. So it's a little more universal. Sometimes a little more technical to figure out, but it's not terrible. So yeah, bear with me. And as always, I encourage you to take notes, because you can use those on assessment. There's no guarantee I'm going to give you that formula. So yeah, there we go. All right, the distance formula. Distance D between 2 points, x sub 1, y sub 1, and x sub 2, y sub 2 is found by D equals the square root of the quantity x sub 2 minus x1 squared plus the quantity of y sub 2 minus y sub 1 squared. Okay, that looks terrifying. Basically, you want to figure out the horizontal distance between the x values and square it, hence Pythagorean theorem. Then find the vertical distance, the distance between the y values, and square it, hence Pythagorean theorem, right? So you're going to see that it's basically the same thing as using the Pythagorean theorem. We're just setting it up in a way that can often look a little confusing. So, but bear with me. All right. So the first one, we're actually going to do the technique we learned last video and use the distance formula. So before I do that, let me go ahead and just copy this real quick. Nope, don't want to do that. There you go. I'm going to copy this and just move it so we can see it a couple different places. I don't have to retype it. It's going to drop it in here a few times. All right, so it's there. All right, that's done. Should have did that earlier. My bad. All right, so let's go ahead and start by using the Pythagorean theorem technique. So we're going to put my point at 1, 2. So 1, 2. I'm going to put my second point at 4, 6. All right, I'm going to go ahead and insert a line to connect those and label it C. So go back to draw. This is C. I'm going to zoom in to make it a little easier to see, and I'll zoom back out when we're actually using the Pythagorean theorem. So here's my one leg. Here's my second leg. There's my right angle. My hypotenuse is opposite. So now we're going to go ahead and just count. So we have 1, 2, 3, 4. So that's 4. Let me make it in a color that's easier to see. And this one is 1, 2, 3. So put that 3 there. So now if you remember Pythagorean triples, you might realize, oh, hey, that's a 3, 4, 5. Let's go ahead and prove it. So that's the one Pythagorean triple that'd be most useful to know, just FYI. So we have 3 squared plus 4 squared equals C squared. 9 plus 16 equals C squared. 9 plus 16 is 25. Okay. This one I don't need a calculator for. I know that the square root of 25 is 5, so C equals 5 units. All right, so that's using the old technique. Now the new technique, let's start by labeling our coordinates. So it doesn't matter which one you call the first one, which one you call the second one. Generally speaking, the first coordinate will be the one that has a smaller x value, and the second point will be the one that has the larger x value. Since we are squaring this right here, it doesn't matter which one you put where, because a negative multiplied by a negative, so if like we have -5 squared, -5 squared is 25. 5 squared is also 25. So if you switch the order of your coordinates, you're still going to get the same answer, as long as you remember that a negative value squared is positive. All right, so just keep that in mind. Be careful though, because your calculator will lie to you. If you plug it in incorrectly and you have certain models, will pump it out as a negative value, so just be careful. All right, a good idea if you have a calculator allow you to put those negative values in parentheses. Might save you some heartache. All right, anywho, back to labeling these. I'm going to call this x1, which means this would be y1. I can call this x2, which would mean this is y2. So let's go ahead and plug that in based on the distance formula. So D equals, okay, 1 minus, my bad, 1 by x, actually, you know what? I'm confusing you guys now. We're doing this the wrong way. I usually just plug the x values in as I see them and ignore that, but let's do it the right way. So x2 is 4 minus 1, that's x1 squared, plus, okay, so y2 is 6 minus 2 squared. All right. Simplify one step further. 4 minus 1 is 3, so 3 squared, plus 6 minus 2 is 4 squared, right? 3 squared is 9. 4 squared is 16. Look at this. We have 9 plus 16 over here. We have 9 plus 16 over there. Huh, imagine that. D equals the square root of 9 plus 16 is 25. I mean, look at that again. It's crazy. Square root of 25, square root of 25. Looks pretty similar. All right, the square root of 25 is 5. So D is 5 units. The distance between the points is 5 units. Now, I'm going to plug these numbers in a different way. And I'm going to show you that why it doesn't matter which one you really call the first point, which one you really call the second point. So over here, we're going to do the same thing again. I'm going to do it quickly. Okay, so I'm just going to plug my x values in as I see them. 1 minus 4 squared plus 2 minus 6. So I basically just plugged them in the opposite way. All right, it doesn't matter. I'm going to keep saying that over and over again. 1 minus 4 is negative 3. Negative 3 squared. 2 minus 6 is negative 4 squared. Okay, now remember, a negative multiplied by a negative is a positive value. So negative 3 times negative 3 is positive 9 as well. So at this point, these are turn into the exact same problem. Okay, now one thing you have to be careful with, though, is you have to remember that a negative value squared is positive. If you put that as a negative, you're going to mess up. So I want to repeat this over and over again. After you get past the point where you square the values, so like, for example, right here, right? Everything should be positive again. Right, keep that in mind. This is by far, it's not, the biggest mistake students make is putting the numbers in incorrectly. The second biggest mistake they make is forgetting that a negative value squared is positive. So just make sure you're aware of that. All right, let's look at another one. This time we're only going to use the distance formula. We're not going to use a triangle to model it. All right, so I'm going to go ahead and label these. This is x1, this is y1, this is x2, this is y2. All right, if you want to pause and try it on your own, I'd encourage you to do that. This one I'm going to plug them in the right way. The next one I'm just going to plug them in as I see them. So, right, so D equals the square root of x2 would be 3. 3 minus 0 squared plus 2 minus 8 squared. Okay, you notice I can have a positive number here after I simplify and a negative number there. It's perfectly fine. So 3 minus 0 is 3 squared plus 2 minus 8 is negative 6 squared. Okay, 3 squared is 9. Negative 6 squared is 36. Not negative 36, but 36. 9 plus 36 is 45. Okay, I know that this is going to be a little bit less than 7 because the square root of 49. The square root of 49 is 7. So, but I have a calculator in front of me, so I'm not going to estimate. I'm just going to plug it in. So I get 6. This is the number it gives me. So I want to round to the nearest tenth. So I look at the hundredths. This is less than 5, so I'm just going to leave that as a 7. So I can say that D is approximately, it's not an exact number, so I need to change this to approximately 6 7/10 of a unit. All right. Okay, so that is plugging them based on which one's the first point, which one's the second point. Next one, I'm just going to plug them in as I see them. So I'm not going to worry about it. I'm not going to label anything. I'm just going to put the x's together and put the y's together. So -3 minus 11 squared plus 5 minus -8. Okay, now if you're putting a negative value in, especially as a second term in a quantity, make sure you include the negative sign. So if we're going to put, it's always going to be subtraction, right? So 5 minus -8. Now, if I am subtracting a negative value, the trick is recognize that it's actually adding because you're getting rid of a negative value. So for example, if you had a bank account, right? And a bank, let's say you get double charged. You went to, you made it up to, I don't know, Mike's Drive-In. You made it to Mike's Drive-In, and let's say they accidentally, you bought a burger and some fries, and they charged you twice for it, right? Your credit card company or your bank account, your bank recognizes that you were charged twice. Your bank takes away, subtracts that charge, which means they're subtracting that amount of money that was taken out of your account, which basically means they're giving you your $8 back, right? So they're basically adding $8. So when you're subtracting negative, it's the same as adding. Going back to the original point, though, make sure you're putting it in parentheses so you remember that you're going to switch that operation, right? D equals square root of -3 minus 11. So this, in this case, I'm subtracting from a negative value. So this would be -14, right? So in this case, let's say you owed $3 and you owe 11 more, which means you owe $14. And then right here, like this is that scenario where they're taking away negative. So 5 minus -8 is really 5 plus 8. 5 plus 8 is 13 squared. Let's pause for a second. If we think about -3 and 11 on a number line, right? So let's say this is arbitrary. I'm going to make it up. Let's say 0 is here. We have -3 here, and we have 11 over here. All right. How far apart are they? Well, -3 is 3 away from 0. 0 is 11 away from 11. 3 plus 11 is 14. Now, we have -14 there. It doesn't matter. We're going to square it. It's going to become a positive value. The key is that the absolute value is still 14. All right, so keep that in mind. You're really looking at the distance between those x values and the distance between those y values. Okay, now let's go ahead and continue using the distance formula. Okay, so -14 squared is the same value as 14 squared. So that is 196. So I have 196. So remember, at this point, all these should be positive. So if you have a negative number, that means your calculator lied to you or you entered it incorrectly. So just go ahead and make it a positive value. 13 squared is 169. Okay, now I find the sum of those two values. 196 plus 169 is 365. Okay, so the number of days in a regular year. You're going to go ahead and square root that value. And we're going to get D is approximately 19 and 1/10 of a unit. All right, now I know this can be intimidating using the distance formula just because it's one of the first formulas you guys have been asked to use. But I wouldn't let you scare you away. So it's essentially just a simplified version of the Pythagorean theorem. Let me restate that. It's the Pythagorean theorem reworked to work in a specific instance. So just keep that in mind. Yes, and that's it. Have a good one.